Hi there, and welcome to today's web seminar entitled Understanding the Top 4 Use Cases for IoT. And now I'd like to introduce today's speaker. Dheeraj Remella is the Director of Solutions Architecture here at VoltDB. He is in charge of the Solutions Architecture team, and should you download VoltDB, you'll receive emails from him as well, welcoming you to Volt and asking if you have any questions. And these emails are actually really from him. Dheeraj works directly with our customers to make sure they understand their goals, and he works closely with the team to make sure that those goals are achieved. So without further ado, I'll turn it over to Dheeraj.
Thank you, Sue, and thank you everyone for taking the time to convene for this webinar. It's my pleasure to be able to present the content that we put together to share our experience in the IoT use cases world. To begin with, something to think about is what has been predicted by Fast Company that within the next 10 years, 40% of the Fortune 500 will no longer exist. When you think of the statement, it's quite profound, but what is the basis of this? It's just that either you adapt or you basically perish, right? So how do you adapt to the modern world? Which is where the whole importance of IoT comes into play, because everything is quantified in this world now. And when you think of quantification, how do you quantify? You need to measure, track, monitor, and act on that. If you don't do that, you will essentially become obsolete very quickly, and upstarts are going to start scraping away at your customer base. So we're going to talk about 4 use cases that we've seen as most widely being adopted in this world in the IoT sense. So before that, I just want to, it's a brief plug. So when you think of VoltDB, who is VoltDB? And basically, it's a Michael Stonebreaker company. It's the same gentleman that invented Ingress, Postgres, Vertica, Streambase, and then VoltDB. So we've been actually able to accrue a lot of customers in telecom and IoT and financial services industries, specifically focused on fast data, because these are the industries that have been actually taking in fast data and adopting it for monetizing the opportunities that are presented. So that's the introduction about VoltDB. Now we're going to just jump into the content. The 4 use cases we're going to be talking about today is what is being done to avoid unplanned downtime and why is it important, along with asset tracking, smart meter management, and fleet management. So these are the most widely upcoming use cases that are adopting IoT. So first, let's talk about avoiding unplanned downtime. Why is it important to avoid unplanned downtime? These are just a few snippets of dollars associated with the cost of true downtime costs, right? So when you look at e-commerce, I know you guys can actually read this as well, but I'm just going to throw out the numbers here. If you look at an e-commerce site, if a data center outage happens for an e-commerce site, they lose anywhere between $40,000 to $100,000 per hour. Then when you look at power plants, it's actually manifesting in 2 ways. One is the actual cost of maintenance itself of nearly $500,000 per year, and also the revenue loss associated with the downtime. And it goes on, right? So there are other industries. We just listed a few of them here. Let's think about what can IoT do to avoid this kind of a cost being incurred. You can monitor, measure, and act on it. The faster you act on the data that you're seeing, the better your planning capabilities are. So when you look at data, every data point is generated because of a real life event. So you can either choose to react to that event and take preventative measures, or you could not do a timely response to an event and miss the opportunity to curb your expenses or monetization opportunities. So one of our customers is a storage device manufacturer, and they basically deploy disk arrays and flash storage across the globe. And what they do is the big differentiating factor for their business, why customers choose them, is because of a 99.9995% availability. How do they accomplish? IoT plays a very key role in it. So a disk array is a storage, but you plant in sensors into it, and now you're starting measuring metrics at various levels and being able to correlate them all together, which is where a VoltDB database plays a key role, being able to ingest data from multiple streams and correlating and collating them according to timestamps and making predictive decisions that's going to yield prescriptive actions. These actions actually help them provide a much better customer satisfaction. When you look at it, the scale at which the disks are performing has to be sustainable, and the nonstop availability guarantee that they provide for their customers means that they need to be predictive about what kind of problems could be occurring. So 9 out of 10 issues are detected before even the symptoms become apparent because they are observing for micro symptoms, which would accrue together and yield a macro symptom. The macro symptom being downtime, unpredicted downtime, right? So to avoid that, they're able to monitor the data and understand what the data is saying. So for this, they need a good marriage of the fast data and the big data. So they use the data warehouse technology to determine what is it that we should be looking for, and they operationalize that in the streaming data processing database, which is VoltDB, and be able to make those decisions. By doing this, they've been able to do away with level 1 and level 2 support engineers because these decisions are automated and already analyzed before it needs to get to a level 3 engineer. The next one we're going to talk about is asset tracking. This is actually a very interesting use case because typically you would associate asset tracking with, say, supply chain management or inventory management. But when you look at the use case that we've been put to, it's a very interesting use case. It's in the casino industry. But before we get into that, why should one track assets, right? So you need to know where your assets are. How are they performing? What is the health check? Inventory control. So there are several types of asset tracking technologies that are in play for a variety of use cases. Is it a long-range tracking? Is it a short-range tracking? Should I use active RFID or passive RFID? Is it a location tracking that I need to know where a particular asset is at any given point of time? I could use GPS for that. So with all these technologies in play, how do you manage this data, right? So there's several forms of data coming in at you really fast because you want to have a continuous monitoring environment. When you are actually getting data from several streams and you need to be able to streamline it, you need to find a technology architecture that streamlines the data flow into an event response chaining. So an event happens in real life, you can respond to it and change the destiny of the asset, of the process, of the sub-process. Or you don't, and you basically receive what the universe gives you as the next event in the life cycle. So the customer that we're going to be talking about briefly here is Walker Digital Table Systems. These guys are based out of Las Vegas and Macau, and they make the smart gambling tables. So in the gaming industry, in the casino gaming industry, the chip migratory patterns, betting patterns, perfect payout, all of these are important metrics that they measure. And the solution that Walker Digital has built leverages VoltDB clusters to incorporate the data that's coming from RFID-enabled chips. And each of the gaming tables actually have small antennas. And based on the signal strength from the RFID to antennas, they're able to isolate which chip is at which player's location, who is the player from the loyalty card, and be able to intertwine all this information together to make sure in a game of Baccarat or a poker, the payout is accurate. So one of the large losses in casino is basically rigged payouts or false payouts. So these things need to be controlled. Otherwise, you're going to be having people that need to work in the security room, walking downstairs, and actually going over to the table to resolve these issues. So this is all time taken away from an active game at the table. So, and anyone that's in the casino industry knows that, like, the more hands that get played on a table, the more chances of the house making profits are. So in this case, it's a smart table that's actually pushing data out to the VoltDB cluster, and in the VoltDB cluster itself, decisions are being made about who is getting what kind of a payout and who is playing what kind of hands, who is the more valuable player, who is actually a loyal player. All of these decisions are made, and these decisions are not just stored, right? So when you think of a traditional database technology, you would think of storing the data, and you have a separate process that comes in and queries periodically to find entities that match certain criteria. In a modern environment, you can't afford to keep polling for information. You need to respond and react to an event in real time, which means when the decision is made, you need to be able to push out a notification or an alert or an alarm that indicates the anomalous behavior or the interesting behavior, as the case may be. And that's where integration with some kind of a messaging layer like a Kafka or RabbitMQ becomes important, being able to send that signal to a downstream system, which is an acting subsystem. What do WD table systems gain as benefits from working with VoltDB? A higher efficiency, higher accuracy, and a better level of integrity. So these are quintessentially the differentiating factors for WD table systems as a business. This is where being able to make in-the-moment decision becomes really important. When you don't do that, you're missing opportunities for a modern solution that's able to handle modern data. Next one we're going to look at is smart meter management. These customers of ours recently went live. We worked with a partner with the government of UK to manage 53 million smart water meters, or smart meters for water. So of course, smart meters are not just for water. They could be used for electricity, utilities. There are many areas where smart meters become important, right? So what are the challenges that utilities are facing that they need to turn towards a technology like smart metering? Being able to have an insight into a consumer spending patterns. This is going to allow the utilities to provide a better experience for the consumer by providing recommendations of when to do what in your house, so you're actually optimally getting your tariffs for your utilities. On the other hand, CO2 footprint is a real thing now, because you actually have to buy credits for CO2 emissions. And by minimizing your CO2 footprint, you can actually save money, perhaps in millions, by not having to go to the exchange and buy more from another company. And of course, the accurate billing is a really important thing, because if you don't do accurate billing in real time, this actually is not just a utilities problem. It's anywhere you're serving something and you are billing people for that. If you don't bill accurately, you're going to end up in a place where you have to do reconciliatory measures. The reconciliatory measures are essentially bad customer experience and expensive for the organization itself in terms of resources allocated for that, the processes and equipment allocated for the reconciliation. So when you look at the flow of data, the smart meters are actually sending data periodically to a meter reading collector infrastructure, and these collectors then feed all of that information into VoltDB cluster for decision making and notifications. The notifications would be if a consumer, say for example, is experiencing a large water utilization in a time that the consumer is not home, it's perhaps a leakage in the house, and being able to notify the customer before further damage is done or the water is being wasted saves money and resources on both sides, and establishes a better, credible relationship with their customers. Now, how do you make these decisions? Again, it's a marriage between the fast data and big data, right? But the big data is only useful as fast as it's able to create new insights. Being able to integrate from the streaming architecture that brings data into VoltDB for decision making into a data lake technology is availing the utilities companies to be able to generate new insights, new predictions, and new prescriptions. And by being able to operationalize them in a short turnaround time, instead of a 2 to 3 month project, you are able to leverage that insight and put it into action before the insight becomes stale. So what does this yield as benefits for the water billing faculty of the Great Britain? They're able to enable real-time billing. They're able to monitor their consumers' real-time energy costs and utilization patterns. And by having that insight, they're able to prescribe to their consumers a better way of using the utility, a better tariff model. So being able to associate the cost to the capability is something that IoT brings to the table, right? And not just that, like when you turn around and actually look at the supply model, you need to be able to optimally utilize the supply of the resource that you're getting in. So effective grid management is a real problem for folks like electricity utilities, where you're receiving your electricity from a variety of sources, not just the production plant, but you're also getting it from individual houses, and how to be ready for being able to route this energy consumption to consumers in the most effective manner. Okay. And of course, the scale at which this work needs to be done is not small anymore. It's a modern connected world, and in the case of UK Smart Meter, it's 53 million smart meters. We also partner with Siemens and Mitsubishi to provide electric smart meter technology in Japan, and we have millions of electric meters there being monitored again similarly, that you have your smart meter collectors, the collectors push the data into a decisioning engine, and you are able to operationalize your predictions and prescriptions in the decisioning engine. The fourth one that we're going to talk about is fleet management. So fleet management, again, now, when you look at fleet management, it's not just the location-based, is my truck in XYZ place, or where is it? That's not just what you're going to look at. The fleet management is a two-pronged approach that is location-based and also being able to look at the fuel utilization, equipment, optimal utilization patterns, and on top of that, now you have wearables for safety, right? So it's wearables technology has gone beyond your smartwatch or smart pedometers, and now it's actually incorporated in helmets and jackets, so they know that if a particular production plant worker or a fleet driver is being asleep, or is he feeling tired? How long has he been driving? He or she has been driving, and should they take a recommended break to be able to be safe and operative? So all of these decisions need to be made in real time, because you can't actually tell a sleepy driver 15 minutes later or a half hour later, like, hey, you're sleepy, because something catastrophic could have already happened, and you want to avoid bad things from happening. Think of IoT as an insurance play in an industrial setup, because what you're trying to avoid is bad things from happening, and to do that, you want to be able to monitor and track and make decisions on the data that you're monitoring. So one of the customers that has put VoltDB to use in such an environment is a mining equipment manufacturer, which they were going to deploy the solution in South Africa for a three-dimensional mining geofence model. And when the mining, what do you call those things, like the trucks, or no, it's not trucks, it's the little things that go on the rails. I forget the name of that. But they need to stay inside of a 3D geometry that indicate that, yes, this vehicle is indeed actually traveling inside the safe environment. It's not broken down. There's not been like a mine cave-in. All of these are being monitored by planting sensors at the appropriate place. And when you actually sense high sulfur content, then you need to notify your workers to move to a safety zone which has a better ventilation shaft. So all of these decisions need to happen in the moment. By being able to take events from a variety of sources of data and being able to collate them and correlate them and making decisions, they provide a safer mining environment for the workers and for the equipment. When you look at the benefits themselves, it's the problems speak to the benefits, right? So when you know what problems you're actually trying to address and what you're actually monitoring, you turn around, and when you successfully do it, those will be your benefits after all. Being able to have safety zones for catastrophes and being able to notify about the availability in the nearest safety zone, being able to improve your fuel utilization, because when you look at mining industry or even any kind of a fleet industry, any kind of idling or any kind of unnecessary fuel is a very, very large cost associated. And if you can actually optimize the utilization of your resources, you're able to serve your needs while maintaining a lower cost basis for the same operation. So, now, on top of the location itself, now you're thinking about onboard telemetry data that comes back to talk about the health conditions of the equipment in play. This kind of connects back to the unplanned downtime avoidance. When you look at fleet, the trucks are actually equipment that's at use, and you want to avoid any unplanned downtime because not only is that going to affect the cost of fixing the problem, but that's the time that particular resource is out of commission. It's not serving the needs of meeting a timeline to complete a project. Being able to geofence them would give you immediate notifications of possible hijacking conditions or theft conditions. We read it like day in and, well, month in, month out, that like, some trucks with some credit card information in tapes backed up have gone missing. And, those are all things that are very avoidable problems by continuously monitoring your assets and fleet. So when we looked at all of these situations, we looked at IoT use cases today, right? But when we actually look at any kind of a modern transactional system, what is necessary to do with the fast data to be able to elicit the value while it's still young data, right? So it's the ability to ingest the data, take that data and either each individual event or a set of contextual events that create some form of a session. You can see the imaginary quotation marks I was doing over here, but the session of being a meaningful set of data that gives you insight into what does this event mean in the near past context. Being able to put that information together and making a decision about what is it that I should do to prevent an anomalous behavior or prevent a catastrophic event from happening because I observe these patterns of events which are indicative of where things are heading towards. And being able to operationalize the big data insights to accurately predict and prescribe necessary actions to be taken. So all of these things together form your fast data processing. What we have done at VoltDB is being able to combine all these capabilities into a single platform, because when you talk real time, when you talk millisecond response time, having disparate systems that are stitched or assembled together to accomplish the end effect, while each layer is performing optimally, you're still not able to meet the overall business objective of a response time within X number of milliseconds, right? So think of advertising, think of telephony. All of these have an overall business SLA for latency. And the only way you can actually do more with less is by combining functionalities and capabilities into a single layer, so there's not a lot of data migratory patterns. So these are the other customers that we have. We touched upon the IoT area, but you can actually look into the variety of areas where a fast data is being adopted, and they need to adapt their processes to leverage the fast data. So the commonality being what we just discussed, right? So ingest, process, decide, notify, and feed into your big data lake. So that's the material we have today. I am just going to open it up for questions and answers. I know I kind of went through it very quickly, but that was by design, so we can actually give some more time for conversations and questions.
Okay, Dheeraj, thanks so much for that great presentation. We have a ton of questions coming in. I'm going to do my best to weed through these here. Some are a little bit longer than others, but the first question that we have is, it pertains to retail stores, and it says, since the hand scanners and checkout scanners collect shopper item purchases and the checkout scanners determine the number of items purchased and processed within a specified by a cashier, wouldn't these also be IoT use cases?
This would be, yes. So someone that we're working with, the ones that we talked about today are the ones that have gone live with us, right? So the ones that have not gone live yet are, a couple of our customers are looking into indoor IoT use case where your store itself is divided into geographical squares. I think they call them panels, if I'm not mistaken. So each area that has specific types of goods that are being sold is actually subdivided as geographical subdivisions inside the store, and you have your Wi-Fi, NFC, and Bluetooth, and even iBeacon, for tapping into the cell phone location of the customer. So all of this get tied together, and you're absolutely right that it would be considered an IoT use case. So it's not just measuring telemetry, right? So it's measuring the location. In fleet management, you're measuring location on a larger scale, while inside of a store, you're measuring location but on a smaller scale, not only your inventory, but also what has been checked out, theft and shrink. All of these things could be measured. You're right.
Okay, here's the next one. What's the biggest challenge to ensure that your data ingestion is 100%? Does that make sense?
Yeah, absolutely. Okay. So when you have, each layer that you have in your architecture needs to be independently scalable and fault tolerant, right? So when you think of a database, we are independently scalable. We're a cloud-enabled, elastic environment, but also you want the same kind of fault tolerance up front also, which is where having a mediation layer like a message queue would be very helpful, because you don't lose the data in case of the database infrastructure going down, or any kind of a node failure on distributed message queue infrastructure. So we partner very closely with Apache Kafka. We've seen a very wide adoption of Kafka. So I don't know if that's something that you're actually thinking of as a part of your infrastructure roadmap, to be leveraging Confluent Kafka or Apache Kafka, however you want to think about it. We solve the challenge by creating a massively parallel ingestion. So when you look at a distributed architecture, you can't have a single point of ingestion. Neither can you have a single point of supply of the data as well. So when you have a distributed architecture for mediation like Kafka, combined with a distributed architecture like VoltDB to be able to ingest the data at least once contract, you basically have almost a foolproof way to ingest your data without losing any samples. The second part is being able to ingest the data at the scale that's necessary, right? So when you look at a traditional database and think a sharded environment could actually do the job for you, you will find yourself short-staffed on that, because the traditional architecture has a lot of waste built into it, which is actually gone in the new SQL re-architected world, especially Dr. Stonebreaker's research. I don't know if you guys are familiar with this paper or not. Something that we can share after this session. So it's definitely scalability, and fast performance, low latency, and having a distributed architecture that's fault tolerant are things that you want to keep in your mind to ensure 100% data ingestion.
Great. Wow. Dheeraj, we just have a ton coming through. Here's one. It says, do the transportation road systems use IoT monitors to track movements, for example, backups, velocity, et cetera?
Yes. So when you look at onboard diagnostics, there's a ton of smart infrastructure built into your transportation systems that are making edge decisions. So when you think of IoT itself, there are three layers, right? So one is the actual edge, which is the gateway that's collecting all of the sensor data, and you're doing a firmware decision making. Then you have the fog computing, which is basically correlating multiple systems together, multiple gateways together, and making sense out of the data. And then, of course, you have the cloud level, which is where your big data resides. IoT itself, when you think of it, in my mind, I broadly think of it as a concentrated deployment or distributed deployment, right? So definitely fleet management and transportation is a distributed deployment. So fog computing is slightly away from being very close to the edge gateway. It will be the first point of entry in the cloud. So with the advent of LTE Advanced and 5G, you're going to be able to send a lot more data. There are also other companies that we partner with, like Push Technologies, that help reduce the payload that goes out. So there's a lot of information that could be sent in a very concise manner into the fog layer, so you're able to make correlative decision making at the fog layer. I hope that answered the question.
Okay, well, Dheeraj, they keep rolling in. How do you eliminate false positives or missed events, which would reduce operations trust in these real-time decisions? Does that make sense?
Sorry, I'm looking at the questions. How do you ensure guarantee? Good. Which one are you reading? Sorry.
It's third one from the top.
Third one from the top. Okay. False, a keyword to avoid downtime. Software false. So.
Nope. This is how do you eliminate false positives?
I see. Got it.
Missed events, which would reduce operations.
Okay. So that's part of the decision making, right? So that's basically your business rules that actually detect false positives. Missed events is something that's one of the first questions that we got, right? So the 100% data ingestion. So what you don't want to do is have mini batch and micro batch processing, which are basically going to separate relevant events away. So when you look at something like a Spark or Storm event, Storm does per event processing, while Spark can do aggregated messages in a small time frame. But the problem with that kind of setup is without the holding state component built into it, you are going to end up with events that got separated. While they are actually contextually relevant to be together, you would actually have set of events that are separated between two batches, and that could actually yield possibly a bad decision. So, but having a unified layer that's able to process the decisions, not just by event, but also contextually, because it's actually holding all of the events necessary within the contextual window together, is going to help you identify false positive in a much more efficient manner. Think of deduping. Think of checks and balances values that you could actually send to make sure that it is indeed not a false positive. It's custom business rules. So when you look at a transaction construct of VoltDB, you can basically use SQL for interacting with the data store, but you can write your own Java code to enrich those business rules that act upon that data. So by being able to incorporate those rules and being able to apply them as the data is streaming in, you could avoid a lot of the false positives. So it's a valid risk if you don't process it the right way, that you would actually reduce the trust in the operations from the business and management folks that, like, okay, we spent X amount of money, but we are still actually acting on things that are not true.
We have tons more questions before I get into them. Just a reminder, because we're getting a ton of questions about this, we will be sending out both the slides and a recording of this webinar within 48 hours, so not to worry, you will get those in your email within 48 hours. Next question that we have here, Dheeraj. Does a network of VoltDB installation support two-phase commit?
Yes. So in a highly available environment of VoltDB, we basically make sure, so this actually goes to our Jepsen testing. I don't know if you guys are actually familiar with Jepsen testing or not. It basically is to validate a given distributed database architecture supports the promises the organization is making. So one thing that VoltDB promises is consistency of data across your cluster. So in a highly available environment, what we guarantee is that we make sure that all replicas of a given data set are already updated before the so-called commit is transmitted back to the client application. So yes, VoltDB supports a two-phase commit.
Okay, sounds good.
Comes to them.
We got another request for the slides. Again, a reminder, we'll be sending those out in 48 hours. Here's an interesting question. You touched on it a little bit, Dheeraj, about Jepsen, but maybe you can just confirm here. The question is pretty simple. Is VoltDB free of bugs?
I don't know how to answer that question. Like, I think any software would have bugs. It's probably small bugs, but we strive, before we put out a feature or a capability, we strive to make sure that it goes through several hundreds of nightly tests for continuous integration before we actually say, okay, this is production ready. So we give it our best to make sure that there are no bugs, but if there are bugs, we work with the customers to provide immediate patches depending on the severity level. I don't know if that answered the question.
Maybe it might be important to point out that since we are an operational database and most of our customers do rely upon us for mission-critical applications, tracking IoT, for example, telco in specific, to make sure that your networks don't go down. So our reliability and our ability to be up and running all the time is remarkably important to us. And as Dheeraj had mentioned, we did do the Jepsen testing over the summer, and now nightly VoltDB goes through Jepsen test, correct?
Yep. We have integrated that into our CI environment, yes.
Okay. Let's see. Wow, they're just piling in here, Dheeraj. So there's a question here about security, security models and what we use as a framework for software development. Is that something that we want to touch on, or?
We could give a brief overview of what we do. We have security model that we use is role-based access control that you can actually implement within VoltDB, or we can integrate with Kerberos for securing access to your data. As far as a framework, not sure like what exactly you're looking for as a framework, but the constructs that we use is the core data storage engine, and the transaction processing layer is built in C++, while the network interaction and the transaction queuing, all of that is done in Java to provide an easier programmatic model around VoltDB, but the core itself is C++. I hope that answered the question. If not, please feel free to shoot an email for specific details that you're looking for, and we can make sure that like you get the correct answers that you're looking for.
We're going to try and wrap up now, so if there are any other questions that you guys have, please shoot them in. Go ahead.
I see a person actually posted the question twice. I want to make sure that I honor that.
Yeah, go ahead. No.
For power utilities and oil and gas companies, how do you access their data and ensure data security for clients, since these companies are very sensitive of their data? This is something that we've actually come across. So from a security standpoint, there are ways to secure access levels for the data that's inside VoltDB so that only permitted resources or clients or applications or people have access to the right levels of data, and that's the RBAC role-based access control that I was talking about earlier. And again, of course, if you already have a Kerberos security model pre-built, then we can work with that as well. Data security, consistency, and availability is quintessential for us, which is why a lot of financial organizations and telecom organizations rely on VoltDB to provide that nonstop experience for their core infrastructure. I hope that answered the question. If you have further details that you would like to see, please feel free to email us. Then we can take it offline and have a deeper discussion. This last question, what about IoT in the healthcare industry? It's a real thing, right? MIoT is the sister of IoT. We don't have customers right now in that space, but that's something that we are open to investigate. If you have a specific use case that you would like to discuss, we're all ears. We want to make sure that we are there for the industrial and medical IoT space as the data processing layer of choice. So we don't have customers in that space right now. But from monitoring standpoint, it's very interesting for me. One of the things that I came across, I think like a few months back, is the tattoo style heart arrhythmia monitor, which is super cool and awesome. That it's not like a big box that a patient needs to like tie to their chest and walk around while it's syncing up periodically. Instead, this is like a body heat powered tattoo style arrhythmia monitor that could actually just go over the Wi-Fi and talk and send the patterns. And I think it's a great industry to be in and be able to make smart, fast decisions. But we're not active there right now. So I think that's about what we have.
Yeah, we do have some more in, but Dheeraj, I think it might be better for you to take them offline. So any other questions, feel free to shoot us a note through the portal there. We'll do our best to have Dheeraj follow up and answer all of your questions. Again, thanks so much for joining us at VoltDB, and we'll connect with you next time. Take care.
Thank you very much, everyone.